A company had the following results for the past 5 years on its portfolio. Right, we've been given the years, annual rate of returns, which are also called the holding period yields. Okay, 2017, 11%, 2018, 7%, 2019, negative 6%, 2020, 12%, 2021, 4%. So, in addition to the statistics provided above, inflation averaged 7% and interest rates are projected to average 12% for the next 3 years. Compute the standard deviation of the results. All right, so let's get this information there. Okay, so let's see, we have these results here: negative 11%, 7%, negative 6%, 12%, 4%. Then they've projected 12% for the next 3 years, right? So this inflation is only going to affect the returns that we've projected in the future. These past returns, the historical returns, they're not going to be affected by inflation. Okay, it's the past, it's already gone. But the projected returns are going to be affected by the inflation. All right. So these projected returns from for the next 3 years, from 2022, 2023, 2024, we need to adjust them for inflation. Okay. So this is how we're going to adjust them for inflation. Where's that formula? Yes. Okay. Our real return or our real HPI RR. Okay. Remember, when you talk about something that is real, like real interest rate, real real return, it's just your return or your interest rates adjusted for inflation, right? If you remember in macroeconomics, when we talked about the nominal inflation, then is it the nominal inflation, the nominal rate and the real rate? Yes, we use this formula here. Okay, so the real return is going to be 1 plus the nominal return over 1 plus the inflation rate minus 1. Okay, colleagues, this is how you get how we adjust these projected returns for inflation. Now, if you forget this formula, you can always use this formula: real return, okay, then it's the nominal return minus the inflation rate. So that the formula above will give you an accurate fig. The formula below will give you more of a generalized fig. Okay. Yes. So our nominal return are these returns which we've projected 12%, 12%, 12%. They are not adjusted for inflation. Our inflation rate is 7%. Okay. So to get our real return using the formula above, real return, okay, 1 plus the nominal return, which is 12%, 0.12, over 1 plus the inflation rate, 7%, so 1 plus 0.07 minus 1. So 1 plus 0.12, that is 1.12, over 1.07 minus 1. So 1.12 divided by 1.07, 1.046. Okay. 1.046 minus 1, you get 0.046. When we convert this into percentages, we get 4.6%. Okay. So these 12% returns that we're going to get in the next 3 years, since there's inflation of 7%, remember inflation doesn't only erode the purchasing power of your money, it also erodes your returns. Okay. So these 12%, after we adjust them for inflation, they become 4.6%. If we use the generalized formula, remember the nominal return is 12%. Inflation rate is 7%. 12% minus 7%, 5%. Okay. So have you seen that the answers are near to each other? So that this top formula will give you a more accurate figure. This one below is going to give you like a generalized figure. So for simplicity's sake, let us use 5%, okay? Because 4.6%, we can round it off to 5%. Okay, colleagues? Because in the exam, you don't want to be working with too many decimal figures. All right. Yes. Any questions? So these 12%, so put here adjusted returns. Yeah, here put 5%. These historical ones will stay as they are. Yeah, it's converting it into two decimals. Percent, 7%, -6%. Oh, let me just put it. So here I'll just put here percentage so that we know these numbers are percentages so that I can easily calculate, because Excel convert them into thing. into decimals, adjusted rates. Eleven. Adjusted returns. Yes. So we have first 11%, 7%, -6%, 12%, 4%. So after the 4%, then you have the 5%, 5% here, 5%, 5%. Okay. So now, after we've done the adjustments, we can now start tabulating the standard deviations. Okay. So the standard deviation, first things first, you need to calculate the mean. Okay, we have to calculate what is the average return. Okay, what is the average return? So remember how we get the mean? You just add, remember the mean, the formula for the mean, x bar summation of x over n. So we're going to add these numbers and divide by how many they are. Okay. I believe we still remember how to tabulate the mean. We add 11 plus 7 plus -6 plus 12 plus 4 plus 5 plus 5 plus 5. We're going to get 43. Okay. Then we count how many years do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 years. So the mean return, the average return, 43 divided by 8, 5.375%. Okay, so that is our average return, 5.37%. Any questions? That is step one, calculate the mean. Step two, calculate the deviations. Okay, calculate the deviations. The deviation is just how far each of these returns are from the mean. Okay, so remember the deviation is x minus x bar. X minus x bar. How far each return is from the mean. Okay. X bar. So the mean is 5.37. 5.37. Okay. So we're going to subtract each return x. X represents the return minus the mean to get our deviations. Okay, colleagues, these are the deviations. Okay. So we're going to say 11% minus 5.37%. 5.63. 7% minus 5.37, 1.63. Negative 6 minus 5.37, negative 11.37. Okay, you subtract each return from their mean. Any questions? Then next we square each deviation. Okay, we're squaring each deviation. All right. So meaning this 5.63, we square it. This 1.63, we square it. Sure. How about the others? Okay. So each of these deviations, we square them, okay, colleagues? We square each of these deviations. Oh, sorry, I forgot to write the formula for the standard deviation, colleagues. Sorry. Standard deviation is the square root of x minus x bar. Yes. This is the formula I'm using, okay, colleagues? To get the standard deviation. So once we've squared each deviation, we get the total. We add all these squared deviations. Add all of them, and we get 209.8754. Right? Right. So in our formula here, it becomes square root of 209.87 over, remember n is 1, 8. So 8 minus 1, that is 7. Okay. 8 minus 1, 7. Because n equals 8. Okay. We have 8 years, so n equals 8. Okay. So when we divide 209.8752 divided by 7, we get 29.9. 9.98. Okay. So we say square root of 29.98 is 5.47. Okay. This is our standard deviation, 5.47. Okay. Yes. So the risk is not that big. Okay. The risk is not that big. 5.47 is not a okay, because remember standard deviation, the bigger the number, the more risk that you're incurring. What risk? We're talking about total risk and systematic risk and unsystematic risk. That's the total risk that we are talking about. All right, systematic and unsystematic risk. So risk Standard deviation of 5.47 is very small. This investment is not that risky. Okay. And what you're going to see is the returns are near each other. Because remember, the whole concept about standard deviation is how far on average are the returns from the average. That's what standard deviation is. A bigger standard deviation, it means the individual returns are very far from the average. Okay. But a smaller standard deviation, it means the returns are somehow near the average. Have you seen? These returns, these 11, 5s, and whatever, they're relatively near 5.37. So you expect a small standard deviation. Okay. So it means for a conservative investor, this is good because it means the returns are not fluctuating. Okay. Small standard deviation, your returns are not going to fluctuate. Now, if you had a big standard deviation, your returns will be very far from the average. You'll be seeing 20, 30, negative 20, 30. Yes. Any questions?